Hi folks, we are going to apply what we have talked about for acceleration of gravity to a math problem. Now, if you're feeling confident, please treat this as a try this problem and give it a go on your own, and then come back and look at the results with me to make sure you're on the right path. So here goes. In the part of the world where I live, there is a hospital called Sacred Heart Hospital that's about 100 meters tall. So let's say some evil cad went to the top of this hospital, or let's say there's just a curious science student. How's that for an answer? And this person drops a rock off of this building that is 100 meters tall. The first question we are asked is, how long will it take for the rock to hit the ground? So what are we asking, and how long? Yeah, we're asking for time. So time is a question mark. It is going to travel a displacement of 100 meters, and whenever something is dropped, we know that it is going to be accelerated by gravity at 9.80 meters per second squared. One more thing I want you to understand about objects when they are dropped. Now, at the instant this person lets go with their fingers, what's going to be the original velocity of this object? It's going to be 0. Unless this person throws the object down, which it doesn't say anything about him throwing it, just says dropped, that means it has an original velocity of 0. So if I take a look at this collection of data and I look at my equations, which equation do you think I should use? Well, I think I'm going to use this one. Displacement is VOT plus 1/2 acceleration time squared. And if the original velocity is 0, anything times 0 is 0. So this whole term is going to go away and it's going to go to 0. So I'm going to end up with x is 1/2 AT squared. And I'm solving for time. So let's do a little algebra and solve for time. To get time alone, first thing I'm going to do is I'm going to multiply both sides by 2. 1/2 times 2, that's going to cancel that. So 2x is going to be acceleration times time squared. Just the time is the only thing squared. To get rid of acceleration, I'm going to divide both sides by a. And time squared is going to be equal to 2x divided by a. And do you remember from algebra, how do you undo a square? Yeah, you undo a square with a square root. So I'm going to take a square root of that side, square root of that side. Time is going to be the square root of 2x over a. So this is going to be 2 times 100 meters divided by 9.8 meters per second squared, and the square root of all that. So when I pick up my calculator, time is going to be 2 times 100 equals, divided by 9.8 square root, I get a time of 4.52 seconds. Now let's talk about direction of sine. If you have all of the motion going in one direction, you can call all of the variables positive. Positive displacements, positive acceleration, and this is going to be a positive velocity in that direction. The book and many instructors are going to say always keep down negative. And if you are happy doing that, that's cool, but you have to be really, really careful. If you do that, then this is a negative displacement because it's going down, and this is a negative acceleration. The two negatives will cancel and you will get the same answer. So you choose whichever method you want, but you get the 4.52 seconds. All right, part B, how fast will the rock be going when it hits the ground? Same thing. Hit pause, give it a try, and come back and see what we get. So to try and find the final velocity here, I have to, again, look at my variables, and I now also have time. I've got that 4.52 seconds I can now use as a piece of information to find final velocity. What am I going to probably choose? Well, probably one of the easiest equations that are out there is this one. VF equals VO plus AT. What's the final velocity going to be? That's what we're solving for, so no algebra required. Original velocity is 0, so that term goes away. Acceleration, 9.80 meters per second squared. Time, 4.52 seconds. So I'm going to grab my calculator, 4.52 times 9.80, and I end up with a final velocity of 44.3 meters per second. That's my final velocity. And in my problem, I have said since all the motion's in one direction, I'm going to call all the numbers positive. So positive in this case is going to be downward. If you are choosing to use negative 9.8, this will be a negative, this will be negative, and that negative sign will tell you the object's moving downward. The last part of the problem is, what is this in miles per hour? So let's convert 44.3 meters per second. Get rid of meters, go to miles. There's 1609 meters in 1 mile. Get rid of seconds, go to hours. There's 3,600 seconds in 1 hour. I want to keep hours. Mary got carried away. Seconds cancel seconds. Meters cancel meters. I'll end up with miles over hours. And let's grab the calculator. 44.3 divided by 1609. I hit the wrong button. You do that too sometimes, don't you? 44.3 divided by 1609 times 3,600, and I ended up with, I definitely did that wrong. I got to do that again. Sorry, you probably have this a long time ago. And then times 3,600. I'm just poking my button slow. I ended up with 99.1 miles per hour. Boy, howdy, do not fall off of a 10-story building. You're going to hit the ground going fast, very, very fast. All right, you guys. I hope that worked for you. We're going to do another gravity one, the next example. See you then.